So what we talked about yesterday is just the rules for symmetry based on whether the graph is symmetric with respect to the y-axis, which means it's an even function, whether we have symmetry with respect to the origin, which means it's an odd function. Remember, origin starts with O and odd starts with O. Or we could have, we also talked about symmetry with respect to the x-axis. But today we're going to look more specifically at a graph in symmetry, and we're going to look at it through the table, and then we're going to look at it algebraically. And the first function that we're looking at is f of x equals x squared plus 2. And the first thing that we can do is we can go to our calculators and we can type in y equals x squared plus 2. And we can see the picture here that we're going to be drawing on our grid here in a moment. But we can look at the table and come up with those values. If we go to second and graph, that gives us our table here. And on our table that I have listed, we're looking at points negative 3, 11, negative 2, 6, negative 1, 3, etc. So let's fill those in. And again, it's negative 3, 11, negative 2, 6, negative 1, 3, 0, 2, 1, 3, 2, 6, and 3, 11. We can graph this on the coordinate plane, although not all the points are going to fit on there. But we get negative 2, 6, negative 1, 3, 0, 2, positive 1, 3, positive 2, 6, and there is a picture of our quadratic there. This is a quadratic. And we want to identify the symmetry. So if we look here, do we have symmetry with respect to the x-axis? No. Do we have symmetry with respect to the y-axis? It looks like it. And when a graph is symmetric with respect to the y-axis, that means that this kind of function is an even function. When we come over here and we look at the table, it says, what do you notice? Well, if something is even, that means if our point AB is on the graph, then it means that the point negative AB is also on the graph. And if you look at this, we have the value negative 3, 11, and then we have the value positive 3, 11. The negative 3 changed sign to a positive. Negative 2, 6, we also have positive 2, 6. So we have the opposite of negative 2 to give us positive 2. It also works with negative 1. Negative 1, 3, we have positive 1, 3. The opposite of negative 1 is positive 1. And there we have that. So we see the graph. We see the table here to help us identify that. We can also identify symmetry one more way, and that's this algebra way. And what we're going to do is we're going to evaluate our function, the given function here, f of x. We're going to evaluate it when we put in the value of negative x. So if we fill this in, f of negative x, we're going to take that value of negative x and we're going to put it back into our function of x squared plus 2. And what that means then is that negative x is going to go in here. So it's going to be negative x squared plus 2. And then negative x squared. Squared means times itself, so that's negative x times negative x. And that ultimately gives us positive x squared plus 2. Well, what we've done here algebraically is we've looked at f of negative x. We want to compare that value. So in other words, what we just came up with, we came up with x squared plus 2. That's our value of f of negative x. We want to compare it back to the original function. Well, f of x, when we compare it back to the original function, we get x squared plus 2. And because these two values, the red value and the blue value, are equal, then what this means is this is the test for symmetry over the y-axis. It's an even function. So let's look at the next one here. And it's nice, if we look at the picture, then we already kind of know what to expect. And then we can do our algebra test to answer any further questions. So when we look at this one, let's go back to our calculator and type in x cubed minus 4x. Go to y equals, and we clear out x cubed minus 4x. And let's just look at our picture just to get an idea of what we're going to be graphing on our paper. But really, what we're going to be more interested in is how do we get that graph. And if we look at the table, we can figure that out here. So here's some values that we can fill in for our table. So just reading straight off the table then, we've got negative 3, negative 15, negative 2, 0, negative 1, 3, 0, 0, 1, negative 3, 2, 0, and 3, 15. And clearly we can't fit all of those points on our graph, but we can get some of them on there. So we've got negative 2, 0, negative 1, 3, 0, 0, positive 1, negative 3, 2, 0, and then 315 doesn't fit on. But we can still get the idea of the picture, and we've seen it on our graphing calculator screen. But our picture roughly looks like that. Can we identify the symmetry from the picture of the graph? Maybe, or maybe not. We think it's odd. And odd means that it's going to be symmetric with respect to the origin. And if you can't tell from the picture, then maybe we can tell from the table. Because what we have is we have negative 3, negative 15. And then if we look down here, we also have positive 3, positive 15. We changed both of those signs. We have negative 2, 0, and then we have positive 2, 0. 0 doesn't have a sign, but we did change the signs on the x's. Or negative 1, 3, and then we have positive 1, negative 3. What do we notice? Well, I hope that we notice that we changed both of those signs, which means that our graph is symmetric with respect to the origin. Well, how do we show this algebraically? Well, the way we show it algebraically is we use these two functions, f of negative x, and we're going to compare that back to negative f of x. That means that we're going to negate this entire function. But we'll start with f of negative x. And we're going to take that value of negative x, and we're going to put it back into the function that we're given, which is x cubed minus 4x. Now that value of negative x needs to replace all of the x's in the function. So we're going to put this in here, and we're going to put it in here. So in other words, we end up with negative x cubed minus 4 times negative x. when we simplify that a little bit, it's because it is fairly abstract. Negative x cubed means negative x times negative x times negative x. And we have 3 negatives this time, and consequently, we're left with negative x cubed. Over here, minus 4 times negative x gives us plus 4x. And what we're going to do now that we've figured out the left side of this equation, f negative x, is let's go the other direction. Well, not the other direction. Let's figure out the other side. And what the other side says is that we're going to take our function of x cubed minus 4x, and we're going to negate the entire function. So in other words, we're going to put a negative in front of that function. And ultimately what we want to do is we want to compare the answer on the left side of the equals to the answer to the right side of the equals, and we want them to be the same. So if we distribute this negative, what ends up then is we end up with negative x cubed plus 4x. Negative times negative is positive. Did we end up with the same value? And we did. And what that does is it's an algebraic way of proving that this function is an odd function. For those of you absent yesterday, it's probably looking kind of funky. But let's try another one here. Because the first one, you're kind of getting, yeah, what's she kind of doing? And the second one, you think, well, maybe I kind of sort of get it. So hopefully on a third example here, we will. And let's start like we have the other two. Let's draw the picture on our calculator. And so we're going to go to y equals and alpha y equals. And our function is x divided by x squared minus 1. And when we look at the picture, I especially want to look at this picture here. Look at that. So let's at least try to get a little bit of a sketch, and we can get our sketch from filling in the table. Go to second and graph. We look at some values here. I'm going to scoot it down a little bit because I start with -3. But just to get a little bit more of the picture there. But ultimately, what we see as we fill in the table and fill these in is that -3 is -3/8. And -2 is -2/3. We get an error at -1. So we don't have any value at -1. 0, 0. We get an error at +1. So there's no value there at 1. 2, we have the 2/3. And 3, we have 3/8. And I'll do my best to draw this picture, but we do have fractions. So that's the beauty of being able to have the picture on the screen and at least get a rough sketch on your graph. And so here's my middle branch. And then the other two I'll do the best that I can, but it's -3 and -3/8 and -2 and -2/3. Can't really tell the difference up here. And it kind of looks like that. I went into 1 or into -1, and there's not a value into -1, and I may erase that here in a second. Over here, I think without even graphing, I'm going to use my what was in the calculator image in my mind to get that one. And I'm going to try to draw this one more time over here. Maybe draw it a little bit better, or at least I hope I get it drawn a little bit better. So if I do this, no, not any better, but roughly there. And the best thing is that you can go back and you can look at the picture on your screen. There you've got a good picture. So this is a rough sketch, especially here. We don't have very many definitive points that we can put on there. But the question then becomes is this function symmetric with respect to the x-axis, the y-axis, or the origin? And again, if we can't tell from the graph, let's look at the table. We've got -3 and we've got -3/8. And its counterpart is +3 and +3/8. We've got -2 and -2/3, so we also have +2 and +2/3. So those are the two that we can use, and what's happening there is that we've got AB, and then we get -A, -B. So what relates those two? What does that tell us about symmetry? Well, it tells us that it's odd. It tells us that it's symmetric with respect to the origin, which means that it is an odd function. So now what we're going to do is we want to look at this algebraically. And here's our test again that we did. So it would be nice if I could write small enough that we could compare these two. But we've got f negative x equals -f of x. So when we fill this in here, I still can't see the function. So it's going to be f of -x. Once again, we're going to go back into the function that we're given, which is x divided by x squared minus 1. So we're going to take that value of -x, we're going to put it back in for here, and we're going to put it back in for there. So what that means is now we have -x divided by -x squared minus 1. When we look at this a little bit more closely to simplify, we can't do anything with the numerator. -x is going to remain -x. But -x squared means -x times -x. And two negatives. Negative times negative gives us a positive. So this is going to be x squared minus 1. That's what our left side, f of -x equals. Okay? So we're going to compare that, then, to the negated function. So the negated function means, I wish I wouldn't have written in red, but means we're going to have a negative in front of our entire function. And our entire function is x divided by x squared minus 1. Now, these two, this value here, the red value, and our black value with that negative in front of it, they mean the same thing. But sometimes people look at that and they go, oh, they're not the same. But what you need to recognize is we can write our negative directly in front of the fraction, or we could take this negative and we could apply it to the top. Or we could take this negative and apply it to the bottom. But there's only one negative there, so you only put it in one place. So since we have our negative written in the top of our red fraction, I would take that blue negative and write it in the top of our black fraction. if you're unsure about whether it is directly the same value. Some people know that and some people don't know that. So to finish, what we're going to do is we're going to try to draw some pictures. It says use symmetry to imagine functions. So we're going to try to draw some pictures. Sketch. If the function doesn't exist, write DNE. That stands for does not exist. First example here. An even quadratic with a y-intercept of 4. Well, let's put in our y-intercept of 4. Oh, that's lovely. Y-intercept of 4. And it's a quadratic. You remember what a quadratic looks like? So some of you do, some of you don't. Wondering why I wrote it over here. Here's what a quadratic looks like. And so it fits on the graph, and your picture doesn't have to be just like mine. Sorry, the board is disoriented, and I'm not going to be able to get a good picture. Oh, so bad. But there, oh my gosh. In general, that's what it's supposed to look like. We'll try it one more time here. To get a better picture. So once again, y-intercept of 4, better. There we go. There we've got an even quadratic. Well, the next one, a quadratic that is neither even nor odd, that passes through the origin. So we know we have to have value in the origin. But we don't want it symmetric with respect to the y-axis because it's not even. But we don't want it symmetric with respect to the origin. So when we draw this, it doesn't matter to me. I did something like this. There's a quadratic that passes through the origin, but it's not symmetric with respect to the y-axis, nor is it symmetric with respect to the x-axis. Sorry, nor is it symmetric with respect to the origin. We're not talking about x-axis here. Even, symmetric with respect to the y. Origin is the odd function. Number 3, an even cubic function. Well, we could type in a cubic function on our calculator. If we look at just the most basic of cubic functions, y equals x cubed. We had a little bit more complicated one a couple minutes ago. But if we look at this, the most basic of cubic functions, what we see is that it more than likely is, and it's not more than likely, it is, it's symmetric with respect to the origin. So can we ever make a function that's symmetric with respect to the origin right now, even? Symmetric with respect to the y? I don't think so. We can't on this one. This one is does not exist. And to finish, an odd function that passes through the point 3, 2. So here's 3, 2. Remember, if something is an odd function, what we would do is we would change the sign. 3, 2 means that we would also have a value of negative 3, negative 2. And in fact, I did something like this. I put a point at 0, 0. And then I put a point at 5, 0 and negative 5, 0. And there we get an odd function, symmetric with respect to the origin.